My name is Ryan Fortner, and this is my Physics 2 Lab 1 charged tapes. Firstly, I will introduce my experiment, including the purpose and the key concepts behind the lab. Then I will run through the setup and completion of the experiment and the code used for the computational model. Finally, I will answer the what if and the why questions of the lab. The purpose of this lab is to prepare charged pieces of clear tape and observe their interactions. Then we can determine approximately how much deficit or excess charge is on one piece of the charged tape. In this experiment, we're going to treat the pieces of tape as point charges for simplicity. I determined the charge of the tape to be approximately 3.035 e to the negative 9 coulombs. For this lab, it's important that we understand the key concepts behind electric forces. First, there is charge, or Q, which is an intrinsic property that gives rise to electric interactions. The Q of a proton or electron is 1.6 e to the negative 19 C, called E, and is positive or negative depending on whether it's a proton or electron. Then there's Coulomb's law, which says that the electric force is equal to 1 over 4 pi epsilon times the charges over the distance squared. Like charges will repel each other and opposite charges will attract. Finally, there's gravity, which is F equals negative mg. Next, we need to make some assumptions. Tapes A and B are equal point charges. Thus, we can say that the electric force is equal to 1 over 4 pi epsilon times Q of B squared over the distance between the two tapes squared. Then we're going to say that the tape is 1 atom thick and tape B is located at the origin. To create the charged pieces of tape, I placed two tapes on top of each other and ripped the top one off quickly. I expected firstly that if I put two upper charged tapes close to each other, they would repel, and if I put a charged piece of tape near a neutral object, like my hands for example, they would be attracted to each other. My observations supported these expectations. So what is the charge of the tape? By putting a negatively charged pin by the tape after rubbing the pin through my hair, they attracted each other, so the tape must be a positive charge. For this experiment, tape B was chosen as the system as it was still and I didn't have to touch it, and the surroundings was tape A. The net force on B should be 0 as the gravitational and electric forces should cancel out. I measured the length of tape B to be approximately 0.2 meters, thus the mass of B is 0.0002 kilograms after making the assumption that the weight of the tape is equal to 1 gram per meter. After performing the experiment, I measured that the distance between A and B to when B moved up was 0.0065 meters. So setting the gravitational force and the electric force equal, we can find the charge of B to be 3.035 e to the negative 9 coulombs from my previous assumptions. Furthermore, I could calculate the number deficit of electrons in B due to its positive charge by dividing the charge by the constant E to get 1.88 e to the 10 particles. Next, I found the atoms in the tape by dividing the area of the tape by the area of the atom in angstroms to get 2.6 e to the 16 atoms total. The ratio of electrons to the atom's deficit is equal to 1.88 e to the 10 divided by 2.6 e to the 16 to get 1 over 2.6 e to the 6 electrons lost per atom. For my computational model, I've started off by labeling all of the constants used in the calculations. PHYS is equal to 1 over 4 pi epsilon, which is also equal to 99. All lengths are in meters and all forces are in newtons. The charges are in coulombs. From there, we could work backwards to find Q because there are no other forces present besides gravity and electric. So I just set the gravitational force equal to the electric force and solved for Q. Here is the model showing the forces acting on the point charges. Gravity is the orange arrow, the electric forces are the green arrows, tape B is the red point, and A is the yellow point. The distances and force sizes were augmented slightly for clarity's sake. As with any experiment, there is definitely possible error. There could have been human error in the design/completion of the experiment. The charge could have dispersed a bit when I touched the tape. The assumptions I made simplified the model so much that the actual behavior is not accurately represented, and there's also other forces that were not accounted for. To conclude, I'm going to ask two questions. What if the electrons had a positive charge and protons had a negative charge? There would be instead an excess of electrons in the tape, so the signs would change, but the numerical values and repulsion/attraction behavior would remain the same. And why is it important to handle the charged tapes as little as possible? So the charge created will distribute itself into neutral objects due to the repulsive and attractive forces present in your hand. So in order to preserve the charge, you need to touch it less. Thank you for watching my presentation.